Okay, fifth graders, homework tonight. It's all about exponents like we were talking about in class today, right before you left. An exponent is a raised number that shows how many times the number to its left is used as a factor. So 5 squared, or 5 to the second power, means 5 times 5, which is 25. 10 to the third power means 10 times 10, which is 100, times another 10, which is 1,000. 2 to the fourth power means 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Write each of the following as a factor string and then find the final product. So 2 times 2 is 4, times another 2 is 8. So that's the same as 10 to the fourth power. Is that the same one? Sorry, I'm getting confused here with the A's and the B's. So 10 to the fourth power, they actually want us to write it this way, as 10 times 10 times 10 times 10. So we should have 4 of them. 1, 2, 3, 4. 10 times 10 is 100, times another one is 1,000, and then times another one, we need to add another 0, and we get 10,000 for that one. 7 to the second power is the same as 7 times 7. And 7 times 7 is 49. This is 20 times 20, and then we get to do it another time, times 20. 20 times 20 is 40. 4 times 2 is 8. So 40 times 20 must be, well, 20 times 20 was 200, or 400. But we can just write it up if we need to. 2 times 2 is 4, plus 2 zeros is 400, times another 20. We know it's going to be 8 with 3 zeros behind it, so it should be 8,000 for an answer here. Write each factor string using an exponent. So we've got 4 sixes, so it's 6 to the fourth power. We've got 2 11s, so it's 11 to the second power. This one is 9 with an exponent of 3, or to the third power. And this one is 50 to the 1, 2, 3, fourth power, or an exponent of 4. This time, write each of the following as a factor string that does not have any exponents. Then use a calculator to find the product. So you're going to want to go grab a calculator on these. Got mine. Here's our example. 2 times 2 times 2, and then times another third. So when you multiply them together, you'd get 2 times 2 is 4, times 2 is 8, and 8 times 3 is 24. So we've got just a plain old 2 times, now we've got to write 3 3's, times 3 times 3 times 3 times, and we've got 2 5's, times 5 equals, alright, lots of digits to add up on that calculator. We had 2 times 3 times 3 times 3 times 5 times 5. And I got 1,350, but being there are so many of them, you might want to try it again. 2 times 3 times 3 times 3 times 5 times 5 equals 1,350. We got it twice, so that answer must be right. These are ones where there's so many digits, I would suggest double checking each time. Alright, now I need 4 2's, so 2 times 2 times 2 times 2, and then I'm going to need 2 4's, times 4 times 4. Get our calculator ready. Move it off to the side here for a sec. Clear it out. We've got 2 times 2 times 2 times 2 times 4 times 4 equals 256. Keep that in mind. We're going to double check it, see if it's right. 2 times 2 times 2 times 2 times 4 times 4 equals 256. We got it twice, so I'm thinking that must be the right answer. 256. Write the prime factorization of each number, then write it using exponents. So we've got our 40 there, and we're we're going to look at all the digits that make up 40. I'm going to move it off to the side and do one of those factor trees that we tried a few other times, and I'm going to say this is the same as 20 times 2, and 2 is prime, so I know that will be done. And then 20, same as 10 times 2, there's another prime number. And 10 can be broken up into 5 times 2. Here's another prime number and another prime number. It's asking us to write those numbers then. And we've talked about how the order doesn't matter when you're multiplying a large group of numbers like that. So you might have your 2's first or your 5's first, that's up to you. So 5 times 2 times 2 times 2. And then we get to rewrite it. Since I've got 3 2's, I can write it as 2 to the 3rd power times 5, or 5 times 2 to the 3rd power if I want to do it that way. I'm going to do the same thing over here with 90. And you might divide yours slightly differently than mine, and that doesn't mean yours is wrong. We'll get the same factorization just like we did in class. I know my 45 times 2 is going to be 90, so I'm going with that. There's one prime factor. And then I'm going to break this up. I know 9 times 5 is 45, so there's another one. 9 isn't prime because I can do 3 times 3, but my 3's are prime. So now I get to write all of these down as 3 times 3 times 5 times 2. Remember, the order doesn't matter. Since I have 2 3's here, I can write it as 3 to the 2nd power times 5 times 2. Okay, now put the calculators away for the bottom. No calculators down here. We just need to do good old-fashioned work. Might want to do it on the back. And here we go. Stack it up. Am I on the camera? Yep. 6,383 minus 1,342. Make sure they're in columns in a line. 3 minus 2 is 1, 8 minus 4 is 4, 0, and 5. I got 5,041 on that one. My next one is 48 times 15. I'm going to ignore the 1 for the moment. 8 times 5 is 40. Carry the 4. 5 times 4 is 20 plus 4 more is 24. I'm done with this. I'm done with this. My 1 is in the tens place, so I need to put a 0 there to show it's in the tens place. 1 times 8 is 8. 4 times 1 is 4. Add them up. 720. Here we've got a division. We've been hitting that hard in class the last couple of days. 354 divided by 7. 7 doesn't go into 3, but it will go into 35 if I look at it just that way. 7 times 5 is 35. Subtract and I get 0. We'll bring down the 4. Now 7 doesn't go into 4, and 4 will be a remainder. However, we need a digit up here to show that it was a 0 here, because 7 won't go into it. So we need to leave it as 50, remainder 4. And this is one where you just want to use some reason with it. We know that 7 times 5 is 35, so there's no way that 7 times 5 could have been 354. It had to be 50. I've also showed you another way to write this as 50 and 4 over the divisor, 4/7, which is my preferred way to do it now that you're in 5th grade. 50,314, and we're going to add to it 48,826. Try and stack them up neater than I did. 6 plus 4 is a 10. 2, 3, 4, 8, 9, 10, 11. Carry the 1, 9, and 9. 99,140. And now we've got 84 divided by 7. Let's look at our first digit. It will go in one time, and then I can subtract. Bring down my second digit, and I get a 4. 7 times 2 is 14. Subtract, and I get 0. So this one would be a 12. In our last one, we've got a little multiplying to do. 701 times 68. Stack them up correctly here. We're going to ignore the 6 to begin with. 8 times 1 is 8, 8 times 0 is 0, and 7 times 8 is 56. Bring down the 6, nowhere to carry the 5, so we just write it down. We're done with the 8. The 6 is in the tens place, so we need to put that 0 there. 6 times 1 is 6, 6 times 0 is still 0, and 6 times 7 is 42. Add them up. 8, 6, 6, 7, 4. 47,668. All right, that's it. Thanks for working with me today.